So I'd like to bring on Xing now, who's going to be telling us about just what can we expect in the storage landscape, what's coming, what's new, what's coming up. Xing, very nice to have you with us.
Thank you.
It's all you. Go for it.
Okay. Hello, everyone. My name is Xing Yang. I work at VMware in the cloud storage team. I'm a co-chair of CNCF Tech Storage and a co-chair of Kubernetes SIG Storage. Today, I will talk about what's coming in Kubernetes storage. Here's today's agenda. I will go over SIG Storage GA features in 1.22 release and the features that we are working on for 1.23 release. And I will also talk about what we are doing in the data protection working group in Kubernetes and some of the cross-SIG projects. There are two GA features in 1.22. The first feature I'm going to talk about is CSI Windows. There are challenges for CSI drivers to work on Windows because Windows containers are not privileged yet. However, CSI drivers need to perform privileged operations such as mount, unmount, formatting a disk, and so on. So the solution is to have a privileged proxy named CSI proxy that runs as a native Windows process on the Windows hosts. CSI proxy will expose an gRPC API for executing privileged storage-related operations on Windows hosts on behalf of Windows containers like CSI node plugins. And supported protocols include NTFS, SMB, and iSCSI. Only CSI node RPCs need to be implemented by CSI drivers to support Windows. Another thing I want to mention is that this CSI proxy approach is designed based on the assumption that Windows containers can't be privileged. However, now there's also an alpha version of privileged Windows containers. CSI Windows team is working on designing a solution to transition CSI proxy for Windows to privileged containers. The goal is to make sure minimal changes are required for CSI drivers already supporting CSI proxy to move to privileged containers. The next feature I'm going to talk about is this pod service account token. This feature moved to GA in 1.22 release. It allows CSI drivers to impersonate the pods that they mount the volumes for. This improves the security posture in the mounting process without handing out unnecessary permissions to the CSI driver's service account. This feature is especially important for secret handling CSI drivers, such as the secrets store CSI driver. Because these tokens can be rotated and short-lived, this feature also provides a way for CSI drivers to receive node publish volume RPC calls periodically with the new token. Next, I want to talk about a few features that we are targeting GA in 1.23 release. The first two features are related to FS group. The first one is this skip volume ownership feature. If there are lots of files on a volume, Kubernetes will do a recursive change of all files on the volume every time the pod starts, and that can slow down the pod startup time. So we introduced this skip volume ownership change option, so user can opt out by setting a flag in the pod security context. This feature is targeting GA in 1.23. The second one is this CSI driver FS group policy. Sometimes FS group cannot be applied to volumes at all. For example, if the volume is an NFS share with root squash option. So we have this FS group policy feature for CSI driver to opt in. This is also targeting GA in 1.23. And the third one targeting GA in 1.23 is generic ephemeral volumes. This feature allows any existing storage drivers that support dynamic provisioning to be used as an ephemeral volume with the volume's lifecycle bound to the pod. This allows a PVC to be created as an ephemeral volume along with the pod. This PVC can be used to provide scratch storage that is different from the root disk. This ephemeral PVC will be deleted when the pod is deleted. There's need to write a special driver. All storage class parameters for volume provisioning are supported, and all features supported with PVCs are also supported. This includes storage capacity tracking, snapshotting, cloning, and volume resizing. And now I'm going to talk about a few features that are in beta in 1.23 release. Some storage systems can apply FS group more efficiently by applying it to the whole volume, for example, as a mount option. So we introduced a feature in 1.22 to delegate FS group to CSI driver instead of kubelet. And this is targeting beta in 1.23 release. The second feature targeting beta in 1.23 is volume populator. This feature allows you to create a PVC from any external data source, not just another PVC or a volume snapshot. For example, this can be used when restoring a volume from a backup. The third feature I want to mention here is CSI migration. There is an ongoing effort to migrate in-tree cloud providers to CSI drivers, and this is already beta. In-tree cloud providers are deprecated and targeted for removal in 1.24 release. And shown here, we have AWS EBS, Azure Disk and File, OpenStack Cinder, GCPD, vSphere Volume. These cloud providers are all deprecated and targeted for removal in 1.24. And the last feature on this slide is volume expansion. This feature has been in beta for quite some time now. We have been working on fixing issues before moving it to GA. Now I want to talk about a few features targeting alpha in 1.23 release. The first one is recover from resize failure. This is one issue we're trying to fix for the volume expansion feature. If the storage system can't expand the volume to the requested size due to capacity constraint, currently there is no way to recover from this. There is a design proposal to address this issue by allowing the user to retry with a smaller value. This is targeting alpha in 1.23. And the second one is this new access mode, read-write once pod PV access mode. CSI spec supports several access modes. Single node writer means that the volume can only be published once as a read-write on a single node at any given time. But there's a problem on how this access mode is used during node publish volume, which is when volume mounting is happening. The CSI spec says that when node publish volume is called a second time, for a volume with a single node writer access mode and with a different target path, the plugin should return failed precondition. For CSI plugins that strictly adhere to the spec, this guarantees a volume can only be mounted to a single target path, which means the single node writer restricts access to a single pod on a single node. This behavior conflicts with the original definition. Because of that, we do not have an access mode that represents multiple writers or multiple pods on the same node. To solve this problem, in CSS spec 1.5, we introduced the two new access modes. We have single node, single writer, that is corresponding to the new access mode read-write once pod. And single node multi-writer is corresponding to the existing PV access mode read-write once. And if it's a CSI driver does not support this new access modes, then the behavior does not change. And the third one I'm going to talk about here is This alpha feature, volume health monitoring. Without volume health monitoring, Kubernetes has no knowledge of what happened to the underlying volumes on the storage system after a PVC is provisioned and used by a pod. With this feature, CSI driver can communicate with storage systems and find out what happens to the volumes and communicate back to Kubernetes. So Kubernetes can report events on PVCs or pods if the volume condition becomes abnormal. In 1.22, we moved the volume health monitoring logic from the external node agent to kubelet. And in 1.23, we are working on adding volume health status to metrics on the kubelet side. And from the controller side, the external health monitor controller is alpha since 1.19 release. And there are a few more features targeting alpha in 1.23. The first one on this slide is a COSI container object storage interface. This is a sub-project in Kubernetes SIG Storage trying to bring object storage support in Kubernetes. This is modeled after CSI, but it is different from CSI. CSI is for provisioning file and block storage. File or block volume is mounted on a pod so that a pod can access to the volume. COSI is for provisioning object buckets. An object bucket cannot be mounted. It is accessed through network. Also, object storage has more fine granular access control. COSI defines Kubernetes APIs to provision object buckets and provide access. COSI also provides gRPC interfaces so that a storage vendor can write a plugin to provision object buckets on their backends. And the second feature listed here is this preventing volumes from being leaked when deletion is out of order. This means that PV reclaim policy should always be honored. If it is a delete, then volume on the storage system should be deleted when the PV is deleted, regardless of whether PVC or PV is deleted first. This is targeting alpha in 1.23. There are also a few other features that are still in design or prototyping phase. I included links for your reference, but I won't go into details here. I want to talk about the data protection working group. This is a working group sponsored by both SIG Storage and SIG Apps. The data protection working group is organized with the goal of providing a cross-SIG forum to discuss how to support data protection in Kubernetes, identifying missing functionalities, and work together to design features that are needed to achieve the goal. I want to highlight two features that the working group has been working on. The first one is container notifier. This is for quiesce and unquiesce hooks. We need these hooks to quiesce application before taking a snapshot and unquiesce afterwards to ensure application consistency. We investigated how quiesce, unquiesce works for different types of workloads. They have different semantics. We want to design a generic mechanism to run commands in containers. We currently have a proposal called container notifier. CAP is submitted and being reviewed. We are targeting alpha in 1.24 release. And the second one is a change block tracking CBT. Without CBT, backup vendors have to do full backups all the time. This is not space efficient, takes longer time to complete, and needs more bandwidth. Another use case is a snapshot-based replication, where you take snapshots periodically and replicate to another site for disaster recovery purpose. Without CBT, we can either do full backups or call each storage vendor's API individually to retrieve CBT, which is highly inefficient. We are currently working on a design for this feature. There are also other projects that SIG Storage is co-owning with other SIGs. I included a few links here for your reference. That's all I have for this session. Thank you all for attending. Bye.